4-inch square box with a single gang plaster ring installed and one outlet has only one outlet. If the single gang plaster ring is removed and replaced with a 2-gang plaster ring, you now have 2 outlets. For a single gang box, there is one outlet. For a multi-gang box, there are multiple outlets, with each point for a device such as a receptacle or switch constituting an outlet. For example, a 4-gang box with a 4-gang plaster ring has 4 outlets. A 3-gang box with a 3-gang plaster ring has 3 outlets. The number of outlets in a box is determined by the number of gangs in the plaster ring or box. The type of devices installed in the box, such as a receptacle or a switch, does not affect the number of outlets. The number of gangs corresponds to the number of devices that can be installed in the electrical box. Each gang provides space and connections for one device, whether it's a receptacle, switch, or other electrical component. Therefore, a single gang box can accommodate one device, a 2-gang box can accommodate 2 devices, and so on. Plaster rings are used to extend the box forward to be flush with the wall surface. They are attached to the electrical box and provide a secure mounting point for devices. Plaster rings come in various sizes to accommodate different wall thicknesses. The number of gangs in the plaster ring should match the number of gangs in the electrical box. For instance, if you have a 4-inch square box with a single gang plaster ring, it is designed to hold one electrical device. If you replace the single gang plaster ring with a 2-gang plaster ring, you create space for 2 electrical devices. This means you can now install 2 receptacles or 2 switches, effectively doubling the number of outlets. In the case of multi-gang boxes, the principle remains the same. A multi-gang box is designed to house multiple devices, and the corresponding plaster ring will have the same number of gangs. For example, a 4-gang box will typically be paired with a 4-gang plaster ring, allowing for the installation of 4 separate devices. The number of outlets is determined by the number of available connection points for devices within the box. Each gang represents a potential outlet. So, a 3-gang box provides 3 outlets, and a 4-gang box provides 4 outlets. It's important to note that the specific type of device installed in each gang does not change the number of outlets. Whether you install a receptacle, a switch, a dimmer, or any other electrical device, each gang still counts as one outlet. This is because each device requires its own set of wiring connections and occupies a separate space within the box. When planning an electrical installation, it is crucial to choose the appropriate size and type of electrical box to accommodate the number of devices you intend to install. Using the correct box and plaster ring ensures that the wiring is properly organized and that the devices are securely mounted. Overcrowding an electrical box can lead to overheating and potential safety hazards. Understanding the relationship between gangs, outlets, and devices is essential for safe and efficient electrical work. By selecting the right components and following proper wiring techniques, you can create a reliable and functional electrical system. Remember to always consult with a qualified electrician if you have any doubts or questions about electrical installations. Furthermore, understanding box fill calculations is crucial for safe electrical installations. The National Electrical Code, or NEC, provides guidelines for the maximum number of conductors, devices, and fittings allowed in an electrical box. These calculations help prevent overcrowding, which can lead to overheating, insulation damage, and potential fire hazards. To perform a box fill calculation, you need to consider several factors. Firstly, the volume of the box in cubic inches. Secondly, the number and size of conductors in the box. Thirdly, the number of devices such as receptacles and switches, and fourthly, the presence of any internal cable clamps or fittings. Each of these components contributes to the overall fill capacity of the box. Conductors are assigned to fill volume based on their gauge size. For example, a 14 American wire gauge or AUG conductor has a smaller fill volume than a 12 AWG conductor. The NEC specifies the fill volume for each conductor size, which must be included in the calculation. Devices such as receptacles and switches are also assigned a fill volume typically equivalent to 2 conductors of the largest gauge size entering the box. This accounts for the space occupied by the device and its associated terminals. Internal cable clamps and fittings also contribute to the box fill. Each clamp or fitting is assigned a fill volume, which must be included in the calculation. Once you have determined the fill volume for each component, you can add them together to determine the total fill volume of the box. This total must not exceed the maximum allowable fill volume for the box, as specified by the NEC. If the total fill volume exceeds the maximum, you will need to use a larger box or reduce the number of conductors, devices, or fittings in the box. It's important to note that the NEC also provides specific rules for calculating box fill in certain situations, such as when using conduit bodies or when combining different conductor sizes in the same box. These rules must be followed carefully to ensure compliance with the code. In addition to box fill calculations, it is also important to consider the working space around electrical equipment. The NEC requires that sufficient working space be provided to allow for safe and convenient access to electrical equipment for maintenance and repairs. This working space must be clear of obstructions and must provide adequate headroom and width. The specific dimensions of the required working space depend on the voltage of the equipment and the location of the equipment within the building. For example, equipment operating at 600 volts or less typically requires a minimum working space of 3 feet deep, 3 feet wide, and 6 feet 6 inches high. Higher voltage equipment may require even greater working space. When planning an electrical installation, it is essential to consider both box fill calculations and working space requirements. These factors play a crucial role in ensuring the safety and reliability of the electrical system. By following the guidelines in the NEC and consulting with a qualified electrician, you can create an electrical installation that meets all applicable codes and standards. Proper grounding is another critical aspect of electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to protect people and equipment from electrical shock. The NEC requires that all electrical systems be properly grounded. Grounding is achieved by connecting the neutral conductor of the electrical system to the earth through a grounding electrode. This grounding electrode can be a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode must be sized according to the NEC and must be installed in a manner that ensures a reliable connection to the earth. In addition to the grounding electrode, the NEC also requires that all metal enclosures and equipment be bonded together and connected to the grounding system. Bonding ensures that all metal parts are at the same potential, which helps to prevent electrical shock. Bonding is typically achieved by using bonding jumpers, which are short lengths of wire that connect metal enclosures and equipment together. The size of the bonding jumpers must be sized according to the NEC. Ground fault circuit interrupters, or GFCIs, are another important safety device that helps to protect people from electrical shock. GFCIs are designed to detect ground faults, which occur when current leaks to ground. When a ground fault is detected, the GFCI will quickly trip the circuit, interrupting the flow of electricity and preventing electrical shock. The NEC requires that GFCIs be installed in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electrical shock. Arc fault circuit interrupters, RFCIs, are another type of safety device that helps to protect against electrical fires. RFCIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when electricity jumps between conductors or to ground, creating heat that can ignite nearby materials. When an arc fault is detected, the RFCI will quickly trip the circuit, interrupting the flow of electricity and preventing a fire. The NEC requires that RFCIs be installed in certain locations, such as bedrooms and living rooms, where there is a higher risk of arc faults. Surge protective devices, or SPDs, are another type of protective device that helps to protect electrical equipment from damage caused by voltage surges. Voltage surges are sudden increases in voltage that can damage sensitive electronic equipment. SPD are designed to absorb voltage surges and protect equipment from damage. The NEC recommends that SPD be installed in all electrical systems to protect against voltage surges. Electrical panels are the central distribution point for electricity in a building. Electrical panels contain circuit breakers, which protect individual circuits from overloads and short circuits. The NEC requires that electrical panels be installed in a location that is readily accessible and that is protected from damage. Electrical panels must be properly labeled to indicate the function of each circuit breaker. The electrical panel must have sufficient capacity to accommodate the electrical loads in the building. The size of the electrical panel is determined by the total amperage of the circuit breakers in the panel. The NEC provides guidelines for calculating the size of the electrical panel. Electrical wiring must be properly installed and supported to ensure its safety and reliability. The NEC specifies the types of wiring methods that are permitted for various applications. Wiring must be protected from physical damage and must be properly supported to prevent sagging or stretching. Wiring must be properly terminated at electrical boxes and equipment. Electrical boxes must be properly sized to accommodate the number of conductors and devices in the box. Electrical boxes must be securely mounted to the building structure. When working with electricity, it is essential to follow all safety precautions to prevent electrical shock and other hazards. Always turn off the power before working on electrical circuits. Use insulated tools and wear appropriate personal protective equipment. Never work on electrical circuits in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. When selecting electrical devices and equipment, it is important to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. Listed products have been tested and certified to meet safety standards. Using listed products helps to ensure that the electrical system is safe and reliable. The NEC is a comprehensive set of standards for electrical installations. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to stay up to date on the latest version of the NEC to ensure that electrical installations comply with current codes and standards. Many local jurisdictions have adopted the NEC as their electrical code. In these jurisdictions, all electrical installations must comply with the NEC. It is important to check with the local building department to determine the electrical code requirements in your area. In addition to the NEC, there may be other applicable codes and standards that must be followed. For example, some jurisdictions may have specific requirements for energy efficiency or fire safety. It is important to be aware of all applicable codes and standards before beginning an electrical installation. Consulting with a qualified electrician or electrical engineer can help to ensure that the electrical installation complies with all applicable codes and standards. Electrical inspections are typically required for new electrical installations and for major renovations. Electrical inspections are conducted by qualified inspectors who verify that the electrical installation complies with applicable codes and standards. Passing an electrical inspection is required to obtain a certificate of occupancy for a building. The electrical inspector will check a variety of aspects of the electrical system, including the wiring methods, the grounding system, the overcurrent protection, and the electrical equipment. The electrical inspector will also verify that the electrical installation is properly labeled and that the electrical panel is properly sized. If the electrical inspector finds any deficiencies, they will issue a notice of violation. The notice of violation must be corrected before a certificate of occupancy can be issued. The process of correcting the deficiencies and obtaining a certificate of occupancy can be time-consuming and costly. It is therefore important to ensure that the electrical installation complies with all applicable codes and standards before scheduling an electrical inspection. Hiring a qualified electrician can help to ensure that the electrical installation is done correctly and that it will pass the electrical inspection. In conclusion, understanding the relationship between electrical boxes, plaster rings, gangs, and outlets is crucial for safe and efficient electrical installations. By following the guidelines in the NEC, consulting with a qualified electrician, and obtaining the necessary permits and inspections, you can create a reliable and functional electrical system that meets all applicable codes and standards.